ChatGPT. Certainly. Here is the properly punctuated version of the text you provided. The universe is a lot bigger than whatever people might perhaps envision. Throughout the last 10 years, there have been intriguing revelations of new universes. Simply this year, NASA affirmed the revelation of more than 5,000 exoplanets, or, on the other hand, extrasolar-based planets. These range from super-Earths to gas giants like Jupiter, to ice giants like Neptune, and other far-off planets. Although planetary researchers have found a large number of these odd, the fact that our Milky Way makes nearby individuals its trusted universe alone has in excess of 1 trillion exoplanets. Now we should show how specialists as of late found a planet so tremendous that it effectively overshadows the size of our nearest neighbor. What is this enormous superplanet, and what precisely do we realize about it? We should find out. The planet known as B Centauri b, or Benter ABB after its discovery, has tested the information of stargazers and researchers alike. This huge planet lies in a climate that was previously deemed too hostile for a planet to develop around a pair of very hot stars. According to the European Southern Observatory, which captured pictures of the planet from its very large telescope in the Chilean desert, no planets had previously been found around a star more than 3 times the size of the Sun until Benter b. As one of the most massive planets of all time found, Benter b is an exoplanet existing outside our nearby planet group and is multiple times as massive as Jupiter. Imre Jansson, a cosmology professor at Stockholm University and the study's head examiner, stated that this discovery completely changes the image of huge stars as planet has the exceptionally huge and hot B-type twin star in the Centaurus constellation. It is at the center of this planetary group. It produces a huge amount of high-energy ultraviolet and X-ray radiation, which strongly influences the surrounding atmosphere and should counteract planet development. It was once thought that it would be extremely difficult for huge planets to develop around B-type stars, as they are believed to be very destructive and harmful. In this harsh environment, everything is on a grand scale. The stars are larger, the planet is larger, and, surprisingly, the distances are greater. According to research, the findings show the way that planets can exist in star systems much more massive than previously expected. Benter b has one of the broadest orbits ever found, measuring multiple times farther than the distance between Jupiter and the Sun. The planet's survival likely depends on its vast distance from the pairs of central stars. Jansson predicted that there would be a general increase in how much time spent searching for planets around high-mass stars, both for finding them and defining them in order to determine more precisely how they may have formed. While we wait for more discoveries, let's take a look at another massive planet that is 10 times the size of Jupiter and is forming in a violent manner. In everyday cooking, a meal can equate to how planets form in our universe. Both the ingredients and the cooking method used to make a planet are subject to change. A planet was observed by scientists using the Hubble Space Telescope as it underwent instability, a violent and dramatic event likened to a flash grill. In this scenario, the protoplanetary disk circling a star collapses and is divided into one or more planet mass fragments by gravity. Instead of forming over time from a small core that gathers matter and gas, Hubble's resolution and lifespan expert to be a significant unaccounted-for part in the puzzle. As astronomers have sought definitive proof of this process as a viable contender in the formation of Jupiter-like planets, the young star, known to be only 2 million years old, is surrounded by a protoplanetary disk of dust and gas with a distinctive swirling structure swirling around it. This is the location of the newly formed planet that generally corresponds to the time during planet formation in our nearby planet group. At this time, the nearby planet group is 4.6 billion years old. The study's lead author, Fei Yen Curry of the Subaru Telescope and AHA Scientific, said nature is clever. It can produce planets in a range of different ways. The raw materials for each planet came from a circumstellar disk. The prevailing idea for the formation of Jupiter's planet is known as core growth, a bottom-up approach in which planets caught in the disk created from tiny debris that orbits a star and then impact and cluster together to produce larger objects. Gas from the disk is then gradually accumulated into this core. The disk instability approach, on the other hand, is a top-down model in which gravity causes a large disk surrounding a star to quickly break into one or more planet mass sections. As the disk cools, the newly formed planet known as a Borg B circles its host star at an extreme distance of